There are two types of common colloidal salts, and they are lyophilic and lyophobic. So what is defined by salt? Salt is actually colloid dispersed in a continuous medium in which the particles are solid and the dispersion medium is liquid. So the differences between lyophilic and lyophobic salts is that lyophilic is solvent-loving, for lyophobic is solvent-hating. So the properties for the lyophilic here, we have the particles of which have strong affinity for the liquid in which they are dispersed. So this will contribute to the strong attraction forces between the molecules and contribute to more stable. And the preparation of the lyophilic salt is much easier by simple mixing, and the particles in lyophilic are not detectable under ultra microscope when the light passes through the solution, and the viscosity is also higher than the dispersion medium. In this case, the viscosity of the particles or the substance. And for the lyophilic also, they have the weak Tyndall effect. For lyophobic, they have an opposite properties than the lyophilic. Since the preparation of lyophilic salt is much more easier by simple mixing, so here in this case we are focusing more on the preparation of lyophobic salt. So there are two methods here. We have the dispersion methods, we have the condensation methods. And dispersion methods are divided into several methods, which are mechanical dispersion, peptization, and Bredig's arc dispersion, or what we call as electrical dispersion. For the condensation method, we have the reduction and oxidation process, we have the exchange of solvent, we have the hydrolysis process, and we also have the double decomposition process. Mechanical dispersion is the method used to prepare substance which to be dispersed and finely ground by using a machine, what we call as a colloidal mill. In this method, the larger particles is being broken down to smaller particles of a colloidal size. Okay, first here the suspension, which consists of the colloidal particle, is being mixed with the dispersion medium, and sometimes stabilizer is also being added in the solution to prevent coagulation. When the suspension is passed through the colloidal mill, the suspension will be pressed or grinded to form a fine particles. And this colloidal mill consists of two metal discs, one at the top and one at the bottom. And the metal disc will be rotated in opposite direction so that the suspension can be grinded. So here the discharge of the suspension or the salt that is already formed the colloidal particles with a small size. So this method also can be used to produce toothpaste, pen, and printer ink. Peptization is a process of converting a precipitate into colloidal salt by shaking it with dispersion medium in the presence of small amount of peptization agent, or what we call as the electrolyte. Here we have the fresh precipitate of iron hydroxide and mixed together with their own dispersion medium, and then we add the iron chloride as the peptization agent. Iron chloride is being used since it has the common ion here, Fe3+, and the solution will be undergo vigorous shaking to form a colloidal particles of iron hydroxide, which absorb Fe3+ ion, giving the colloidal solution a positive charge. So this one is a reddish brown in color. Bredig's arc method or electrical dispersion is the method used to prepare or to produce metal salts like silver, gold, and platinum in water. So in the system we have the stabilizer, the common stabilizer here we have sodium hydroxide, and the special medium is water, okay, connecting water, and we also have the ice bath. In the system also we have the non-conducting vessel. Okay, in this vessel the metal that is being dispersed is being dipped in the dispersion medium, and the metal is in the form of electrodes, and the metal is being connected to a high voltage so that when the electrical is passed through the electrode there will be a stroke at the tip of the rod. So at this point, there will be a melting process since the electrical charge creates large heat and melt the tip of the rods, and this will be evaporated and suddenly cooled down by the ice presence at the surrounding, so that there will be formation of metal salt here, like silver, gold, and platinum in water. For oxidation method here, we have the hydrogen sulfide in water exposed to air or oxygen here. So there will be a formation of sulfur in the form of colloidal. In another way, we can also have the hydrogen sulfide in the form of gas. Okay, and then mix together with aqueous solution of sulfur dioxide to produce sulfur in the form of colloidal. So that one is for oxidation process. Okay, for the reduction process, we have the aurum chloride, aurum 3 chloride plus tin 2 chloride to produce tin 4 chloride and aurum in the form of colloidal. This one is undergone reduction process. Okay, so this one undergone oxidation process. So for the reduction, we have the 2 aurum 3 plus, okay, plus 6 electron, and then we have here 2 Au. And then for the oxidation, we have 3Sn2 plus, okay, releasing 6 electron, and then we also have the 3Sn4 plus. Okay, so for the hydrolysis process, we can also have the iron chloride boiling in water, okay, to produce iron hydroxide in the form of colloidal. For double decomposition here, we have the first step is by hydrolysis arsenic oxide to produce arsenic hydroxide. Okay, and then we boil this mixture and add together hydrogen sulfide to produce water and As2S3 in the form of colloidal. And then for solvent exchange, we have this method which requires the exchange of solvent by pouring the solution of a substance into another solvent in which the substance is less soluble. Okay, for example, here we have a solution of sulfur prepared in alcohol is poured in water, and then the colloidal sulfur is formed due to the low solubility of the sulfur in water. Sulfur in this case is the substance. Okay,